We are UniVirt, that is short for University Virtualization. What is UniVirt? UniVirt is a virtual tour of the Francis Quad in the University of Missouri. Basically, UniVirt allows you to take a campus tour from your own home. We're going to be using Unreal Engine to create the actual game, and we're going to be using the Oculus Rift as the head-mounted display. I am Kyle. I'm the team lead, scrum master, and lead designer. I created the idea for UniVirt. I had a class with these guys last semester, and we worked really well together, so I knew they had a background in 3D modeling, so I wanted to get them all together. I have a design background, so I'm going to be the lead designer, making sure everything is to how I've envisioned University Virtualization.
And I'm Michael. I am the lead level designer and also an artist. As an artist, I will be helping out with the visuals such as the modeling and texturing of the program. And as the lead level designer, I will be in charge of the user interactions with the program, such as where the user can move or walk and how they can interact with the overall environment.
I'm Tim Watson. I'm an assistant designer to Kyle Morrison. I'm an artist and programmer from UniVirt. As assistant designer at Kyle, I will be helping Kyle with the workflow and choices we have to make regarding the game, and as an artist I will be helping with the modeling and texturing aspect of the program, along with I'll be helping Ben on the Unreal script side for the programming part.
I'm Tyler Weiss. I'm lead artist and also a level designer. As lead artist, I will take over for and advise all of the visuals, including the foliage and textures and the lighting for UniVirt.
And I am Ben Riemann. Since I'm the CS major of the group, I will obviously be the team lead for programming. Basically, since we're doing Unreal Script and C++, that's kind of going to be my big task. Also, I will have my hands dirty and pretty much everything up there just to kind of help the team out.
All right, project management. We will be using the Scrum software engineering methodology due to our prior experience with it last semester. The project will be broken up into 4 sprints, each about 3 to 5 weeks in length. And during these sprints, we will be coming together at least every Monday and Wednesday to check up on our progress and adding additional meetings if necessary. And at the end of each sprint, we will be discussing our progress both at the individual and group level to see if we need any more time to go over specific areas of the program.
So the first thing we have to do is prepare a development environment, and that includes downloading some programs that are going to be very important for this game. First one is Unreal Development Kit. We're going to be using the Unreal Development Kit for modeling, texturing, and creating the actual game. We're going to be using Google Earth Pro for some measurements that Tim will talk about a little bit later. And we're going to be using Photoshop for texturing, both the texture, the color, and the bump mapping within Unreal. And we're going to be using GitHub as our source code management, and we're going to create a repository on there. Implementing the Oculus Rift in an Unreal game isn't technically hard as far as getting the plugin from Oculus Rift, but when you're creating a game, you treat it very differently. You have to make sure your latency is very low. You have to keep your frames at 75. Also, you have to keep your code organized and minimized from sensors to rendering those frames. You have to keep the game optimized. Basically, what Oculus suggests you do is there's a little slider for iRender buffer resolution, and you keep that low. And as far as tracking both position of the body and the head, you have to really understand how the user is going to be walking throughout the environment. You don't want them clipping through a wall and being able to see behind that. And also with the Oculus, you can see in places you usually haven't been able to see, under objects and around objects.
To start off the modeling of the quad, we had to take photos of the buildings using close-up shots and perspective shots using wide angles from farther away in order to get the feel of the layout. Besides the photos for perspective or references when modeling, those will not be enough. We will need measurements, and we will use Google Earth Pro to attain those measurements for the height and width of the buildings using the 3D polygon tool. With Google Earth Pro, you can find the height and width and feet of the buildings along with the areas and perimeters of each face of the building if we want that also. Besides the fact of the Google Earth Pro contains the 3D polygon tool, it also has the 3D path tool, which allows us to map out from a building or a certain point to another point or another building in the area, how far that is in distance. What that allows us to do is we can start modeling, let's say, the columns of the quad, and then build out where do we want to start, which side of the quad do we want to start mapping buildings out, like putting them in, how far away is that. The only problem with Google Earth Pro is we don't know yet if you can convert from feet to metric. You might be able to. We still have to find that out, but once we do, if we can't convert from feet to metric in the program, we will have to do that outside of Google Earth Pro, from feet to centimeters, as Unreal Engine uses Unreal units that are equivalent to 1 centimeter. After getting the measurements from Google Earth Pro and the photos, we will start modeling using Tyler and Michael once they bring in the terrain, and we will start modeling the quad with the columns and figuring out where we want to start and where we're going to go from there.
So after we have all the buildings created, we will then start texturing them. We will start by taking up-close photos of the buildings and then uploading those images to Photoshop. We will then turn them into black and white images to create a good bump map for our buildings. After that, we will apply the original photo to the color attribute to give it that nice realistic look. And then for the simpler objects that are located in the quad, we'll just use Unreal's pre-made textures. And then for the foliage, we will just use the brushes that Unreal has given us, such as the grass, the shrubs, and then the trees. And then also for the lighting, we will use whatever Unreal has to give us.
So obviously when you're placed into the game, the user is going to want to be able to walk around freely. As they're walking around freely, we're going to have landmarks that are you're going to be able to interact with. So when you're getting close to a landmark, it should glow in some sort of way. We've discussed 3 different ways of doing this, either having the whole object glow kind of itself a little bit, or have just like a ring around the actual object that kind of glows upward around the object, or maybe like a 3D object inside the game, such as like a little question mark near the object that kind of rotates or something, to kind of let the user know that if they glow close enough to the object, they'll be able to press a key on the keyboard, which will be discussed, and they can listen to kind of like history or just kind of about the object itself, the landmarks and whatnot. Go next slide, please. In the game, actually it's kind of a flow chart of what the game's going to be like. We're going to be hosting a download link on a domain that we already currently have. Once the user can go to the site and download the game, they just need the Oculus hardware to run it and whatnot. Once they run the program, one of the things that we really debated was the start menu. When you're in a 3D game, the start menus can be kind of disorienting, so we're really going to play with that a lot. We're going to either do a start menu or not do a start menu. We're just kind of, like I said, we're going to play with that. If you have the start menu, of course, we're going to have all the basics, the instructions about menu, a start button, of course, and an exit button. But once they're in the game, we're going to have voiceovers. I think Kyle's going to be recording his voiceover, and it'll kind of tell you what to do, what you can and cannot do, just how to interact with items and whatnot, to kind of give you all the instructions you need for the game. Like I said earlier, we'll be able to walk around, but we'll be able to walk around with the arrow keys on the keyboard. There's actually going to be an option for the WASD like any other game as well. And then campus interaction, like I said, you'll be able to read the facts if you're close enough to the landmark, and you'll be able to press the key on the keyboard to listen about it. And then there'll be a way to exit the game, of course, just like any other game. So a little bit about the system architecture. Unreal Engine software is comprised of C++. It works alongside with Unreal Script, which is object-oriented programming. Major programming concepts are derived from Java, and it will look and feel similar to Java, such as the classes, variables, references, functions, those sorts of things. There's a few of us on the team, including myself, that have experience with Java, so I don't think it's going to be too hard to pick up from there. And we can write the Unreal Script in any text editing program, which is nice. Won't be anything too difficult there. And the majority of the game will actually be programmed in Unreal Script, because that's the actual end game. What's going on, that's programmed in Unreal Script, and then kind of behind the scenes stuff is kind of in C++, which shouldn't be as much programming on that side. Then we also made this slide for the users out there, just kind of give them an idea of what they're going to need if they download our game and play our game. Obviously we haven't made our game yet, so we don't really know actually exactly what it's going to be like, but we went online and kind of found other projects that are similar to what we're going to do, and we kind of gathered information from that to kind of compile something that was similar So if you're interested, these are kind of some of the facts that you'll need for your PC to run it.
All right, and finally, the testing of the program. To start off, we'll have a series of alpha and beta tests. During these alpha tests, we will come together as a group and cite potential weaknesses of certain areas of the project at a time, such as the modeling and texturing. Once we feel we have satisfied all flaws and weaknesses, we will begin the beta testing. These beta tests will each include design levels, which will have potential users complete objectives using a linear path to make sure they don't get too out of control. And then users will also be able to give feedback in the form of ratings from 1 to 10 of the overall accuracy and user-friendliness of the program. And users can also give written feedback about areas that they feel we have done well in and areas that need more improvement. And finally, we will be doing more testing and improvements throughout the entire process.